Right, so the basic idea behind the addition and subtraction of algebraic fractions is the determination of the LCD, lowest common denominator. Okay? When you were working with integers, you just called it the lowest common multiple. So the LCM and the LCD are the same. Okay? The lowest common multiple is called the LCD. Okay? When you are dealing with fractions. So whenever you are adding fractions, you have to find or you have to determine a common denominator. That is a denominator that's the same. You cannot add fractions or subtract fractions if their denominator is not equal. Okay? So that's the basic idea. Alright? So I'm going to just start with a simple example. A1. So you have 2x over 3 plus 1 over 6. Now, when you are adding fractions or subtracting fractions, your final answer must have the LCD as part of it. Okay? So you keep writing the denominator. It's not an equation. With equations, we neglect the common denominator, but with addition and subtraction of fractions, we don't neglect the denominator. So here, the LCD, let me just put it like this. Right. So the LCD is going to be a what? It's going to be a 6. Yes. Right? So what that means is we multiply the numerator by 3, so by 2. Okay? We also multiply the denominator by 2. Because the LCD is 6. So how can I make this 3 equivalent to 6? I have to multiply it by what? By 2. Whatever you do to the denominator, you also do to the numerator. That's a basic rule of addition and subtraction of fractions. Right? This will be plus 1 over 6. Okay? Then you end up getting 4x over 6 plus 1 over 6. Right? Now we have the same denominator. Therefore, I can write the sum of the two numerators under the same denominator. So my answer will be 4x plus 1 all over 6. So that will be the answer.
So you can't remove the 6.
No, you can't. It has to be there. Because this is not an equation. Okay, it's not an equation. So the denominator does not go out. Okay, you see the question. Do you see any equal sign? There is equal sign. If you see all these questions, do you see any equal sign? There's no equal sign. Therefore, they are not equations. They are just simplifying expressions. There's a difference between an algebraic expression and an algebraic equation. Okay, these are expressions that we are simplifying. This is a binomial. That's a trinomial, and so on. Are you following that? Okay, so let's do another one which is slightly more complex. Right? Now, algebraic fractions are very, very important in maths because they've got applications in other topics. Okay? So you have to know how to work with algebraic fractions. Okay, so I've done a very easy one. Which one can I do? Two. Okay, let's do number 2. So we have 7 over 6x minus 2 over 9xy plus 1 over 3x squared. Right? Now, please be aware that for this question, our denominator have got okay, in this case, our denominator has got letters. So what you do, first find the LCD of the coefficients. Okay? So our coefficients, right? We have 6, 9, and 3. What is the lowest common multiple of 6, 9, and 3? It's not 9. 6 is not a factor of 9. So it will be 18. Please don't confuse a factor and a multiple. Don't confuse the two. When you are dealing with fractions, the LCD, we are dealing with the multiple, not the factor. Okay? 6, 9, and 3 are factors of 18. 6, 9, and 3 are factors of 18. 18 is a multiple of 6, 9, and 3. Now I'm going back to grade 8 and 9. The lowest common multiple of 6, 9, and 3 is 18. 6, 9, and 3 are factors of 18. Okay? So, we have 18. Now I'm done with the integers. Okay? I'm done with the integers. Now I've got letters multiplying the integers. So I have x here, I've got x there, and then I've got x squared. Now what is the LCM of x, and x squared? Don't confuse the factor and the multiple. Okay? X, and x squared are factors of x squared. Alright. So I'm saying x, x squared, they are all factors of x squared. Okay? But the LCM, the lowest common multiple of x, and x squared, is also x squared. Right? So for this one now, x squared itself is both the highest common factor and also the lowest common multiple. Okay, look here. If I were to ask you and say, what are the factors here of x squared? I'm sure you can say, Mr. Chiponda, x is a factor of x squared. Also, x squared is a factor of itself. Am I wrong to say that? Yeah, x squared, any number, okay, by the way, any number is a factor of itself. Do you know that? Do you all know that? If you didn't know that, then I wonder, how did you finish grade 8 and grade 9? Any number is a factor of itself. And 1 is a factor of any number. Do you know that? So we have 1 being a factor of any number, and we also have any number being a factor of itself. So here, right? Here, x and x squared are both factors of x squared. So what's the highest common factor? X squared. It's going to be x squared. Then, since x squared is the highest common factor, okay, and we want to find the LCM of x and x squared, it means our LCM will also be x squared. Right? So in terms of the x's, it means our LCD must have x squared. Our LCD must have x squared. Then y now, we don't have a y here, we have got a y, we have got x. It means that in the end, our LCD must also have y. It has to cater for this y. Remember, any number is a factor of itself. Okay? Are you following that? So in terms of the y, it's more like we have got a 1 here, and there's a 1 there, then the LCD of 1 and y is y. Are you following? Okay, so that's our LCD. Now the objective is to make every denominator equivalent to that LCD before we start adding and subtracting the numerators. Okay, so let's carry on now. To get 18x squared y, we multiply the 6 by 3, the x by x, then you also multiply that by y. So it means my numerator, I'm going to multiply it by, to be 7 over 6x. I'm taking you to the basics because I'm worried now. Okay? I'm worried. So this will be 3xy over 3xy. So I'm multiplying that first term by 3xy over 3xy. I'm multiplying its numerator by 3xy, the denominator by 3xy. Because whatever I do to the numerator, I do to the denominator. Then minus. Now here I've got 9xy. So I just have to multiply the 9 by 2 to get 18, the x by x. So I'll multiply the numerator and the denominator by 2x. So that will be 2x over 2x. Okay? Then plus. I've got a 3 there to get 18, I multiplied by 6. Then I've got the x squared, and I've got the y. Since I have the x squared here, I don't have to multiply by any term in x. So it means I just have to multiply the 1 over 3x squared by 6y. Okay? So I just have to multiply the denominator by 6y to get the LCD. Once I've done that now, I can easily carry on and simplify. Are you following?
What doesn't the x y?
Are you talking about here? Look, we have got a y in the denominator. We have got a y in the LCD. Therefore, we don't have to multiply this denominator by y. Because if we multiply this denominator by y, we end up getting what? Y squared. We don't want y squared because our LCD does not have y squared. It has got y. So we can't multiply this denominator here. Let me just indicate. You can't multiply. Yes. The numerator won't have y because the denominator has got y already. Okay? Another way is to do it this way. If you want to know which term you are supposed to multiply the numerator and the denominator with, all you can do is divide the LCD, right? Divide the LCD by the denominator you have. Okay? Like example here, if I take 9xy, right? Okay? I'm sure you can agree with me that 9 into 18 will give you a what? A 2. X squared divided by x will give you x. Y and y will cancel. So what that means is we have to multiply the numerator by 2x, denominator by 2x. Is it making sense? Right. So from here, let's simplify. So here I'll get 21xy. Right? So I'll get 21xy over 18x squared y. Right? Minus 4x over 18x squared y plus 6y over 18x squared y. Alright? So, from here now, the denominator is now the same. Therefore, I can write this as 21xy minus 4x plus 6y all over 18x squared y. Yes. Well, what trinomials are you talking about? You can't factorize it. You can't factorize. But obviously, sometimes you might find that the numerator can be factorized, but this one cannot be factorized. You cannot factorize it. So this will be your final answer. Yes?
You can't just have 2x minus 4
No. You can't simplify it. There are no like terms.
No, let me do like that. You don't have to put over 80.
Okay, you can understand what you're trying to say.
Whereas all the denominators are the same. How to drop there, but then you have 21 and the other.
No, it's not an equation. Remember what I said earlier. This is not an equation. It's an algebraic expression. You don't drop the denominator if you are working with algebraic expressions. You only drop the denominator if you are working with algebraic equations. Do you understand that? Later we are going to do equations. That's the next topic after exponents. Okay? When you're dealing with equations, that's when you drop the denominator. These are algebraic expressions, so you keep the denominator. Okay? Or you can simplify if there is a common factor between the numerator and the denominator, then you can simplify. In this case, we don't have a common what? Factor in the numerator. It's not there. So you leave your answer like that. All right.